Bonsuelum athletes. Okay, today, again, what's the main thing we're doing at this point? We're going to take a little bit of a diversion from it today, but what's the main thing? If you have degrees 3 or greater and you can't factor it by inspection, you divide. Okay, that's the main thing. Well, we're going to talk about something here that will aid us in that, but it's going to be, at least at the very beginning, kind of a little bit of a diversion. Okay, this is, first of all, something called the conjugate root theorem, okay? And it says this: if you have a polynomial and a plus bi is one root, in other words, it has an imaginary number there, then a minus bi must also be a root. I've mentioned this name to you before, conjugate. Remember, like, just to give you a quick example. Don't write this down, though, because this is not what we're doing. Let's say you had 2 plus 5i all over 7 plus 8i. And you want to rationalize that. What did you do? You multiply by 7 minus 8i, because that makes the middle term go away. That's what's called the conjugate. These two things are conjugates, okay? So, let me get rid of that. And I'm not that concerned that you know that name. But what is it? If you have a plus bi, you must also have an a minus bi. Okay? So, for instance, here, I'm telling you that this polynomial has 1 minus 2i as a root. What's another root? Well, it has to be 1 plus 2i. You don't need to calculate anything. It's just got to be, okay? If I tell you this polynomial has negative 1 plus square root of 3i is a 0, what's another 0? By the way, I'll mention something in a second. The other one would be negative 1 minus square root of 3i, right? You just change that middle sign. By the way, notice on one of them I called it a root, and one of them I called it a 0. What's the difference? Well, notice this thing starts off equal to 0. A root is just the solution to any equation. Okay, but this starts off p of x equals. So a 0 is the value of x when y is 0. So like you would have to substitute, if we were going to do this whole problem, factor it and everything, you'd have to substitute 0 in for p of x. But the main thing I want you to get out of this is that if 1 plus 2i is a root, then if 1 minus 2i is a root, then 1 plus 2i must be another root. And on the second one, if negative 1 plus square root of 3i is 1, 0, then negative 1 minus square root of 3i must be another one. Okay, so fine. All right, for each example, 1, 0 is given. Write the quadratic, so it's going to be degree 2, for the parabola that has that 0. Okay, well, first of all, I want to remind you, every equation of a parabola starts off y equals a. Okay? Y equals a. Y equals a. All right. Now, how many zeros do we know in this? Well, I know this one's also got 2 minus 3i. Okay? This one's also got 5 plus square root of 7i. And this one would also have negative 6i. Okay. Now, so how do you find factors? Remember, factors are x minus the root. So this would be x minus 2 plus 3i times x minus 2 minus 3i. And the same thing with this one would give us x minus 5 plus square root of 7i. And this would be x minus 5 minus square root of 7i. All right? And this one would be x minus 6i times x plus 6i. Okay, we'll come back to the other ones in a second, but I'm going to do number 3 first because it's the simplest one. First of all, there's nothing particularly unusual here. So for each of these, I'm going to let a equal 1. okay? And I've shown you before when you're going to pick something other than A being 1, but we'll worry about that another day. Okay, so first of all, how would you multiply this out? Well, it's just, okay, so you put an A for 1, so you kind of almost don't have to worry about it. It's just distributive property. X times X is X squared, and then X times 6I is 6I times X, and then negative 6I times X is negative 6IX, and that, the middle term goes away, which I've shown you before. It's plus 6IX, and then distribute the negative 6I minus 6IX, and then minus 36I squared. Okay? Well, what would that be? That would be X squared. The 6IX's go away, and negative 36I squared is going to be plus 36. Okay? Now, let's go back to problem 1, because this is not going to be as easy. Okay. I'm going to show you kind of the long way to do it. And that's fine. You can always do that. And then I'm going to show you the shorter way. It's a little harder to, it's just harder to understand at first. But if you understand it, it's way easier. Okay? So, first of all, we can kind of ignore the A, because A is just 1. So what I'm going to do is distribute the negative, and we have X minus 2 minus 3I, and X minus 2 plus 3I. Okay? And now it's just the distributive property. It's long and tedious, but that's all it is. So I'm going to distribute the X first. So you get X squared minus 2X plus 3IX. And I'm going to stack like terms, which I've done all along. Now I'm going to take the negative 2. So we get negative 2X. Okay, and then negative 2 times negative 2 is plus 4, and there's nothing to put that under. And then negative 2 times 3I is minus 6I. Okay, now let's distribute the negative 3I. So we get negative 3I times X, and then negative 3I times negative 2 is plus 6I. Again, I'm stacking like terms vertically. And then negative 3I and positive 3I is negative 9I squared. Now, this is going to seem kind of weird, but I'm going to take this negative 9I squared and stick it over here. Why? Because negative 9I squared is just plus 9. Okay? So I'm going to take that and put it as minus 9I squared. And now let's combine them. Y equals X squared minus 4X. Notice the 3X's go away. 4 plus 9 is 13. And then the 6I's go away. All right? Now, go ahead and copy that down, but you're going to have to pause the video because I'm going to erase it because I'm going to need some space. And I'm going to do it a little differently, okay? And at first, it's going to look kind of weird. But we'll just see what we can do. And then the second problem here, I'm only going to do it the new way. But you can always go back and do this. Do it by, just distributing the negative and then use the distributive property, right? No FOIL. FOIL doesn't exist. It's just 3 terms times 3 terms. Okay, so I'm going to get rid of this bit of it. And if you didn't get it down, just pause the video, go back and look at it. Okay, now, for this next way I'm going to do it, I distribute the negative again. Fine, I've got that. Now notice that these two are the same. And that this is the same as that. Okay? So what I've got is the difference of two squares. Okay, now I'm going to use parentheses here. And I'm going to put parentheses just on these first two. And now what do I have? In a weird way, it's a binomial. This is the first term, this is the second term, this is the first term, and this is the second term. One of them minus and one of them plus. Now, let me remind you of how to multiply that out, because this is all I'm doing. It's like saying this. It's like saying you have x minus y times x plus y. What happens? You get x squared, the middle term goes away, right? Because you'd have plus xy, and then distribute the negative y minus xy, and then minus y squared. That middle term goes away. So what do you really end up with when you multiply two conjugates? The middle term goes away. So you end up with x squared minus y squared, right? That was the idea of rationalizing multiplied by the conjugate. Okay, so let me get rid of this. You don't need to write that down. Let's multiply. Okay, I'm going to take this times that, and we get x minus 2 quantity squared. Okay? Now here, this is going to seem weird, but now what happens? Because they're conjugates, this times that and this times that they go away because they're opposites of each other. Again, take a look at the way x minus y and x plus y multiply. You end up with x squared, the middle term goes away, minus y squared, because the middle term, they end up to be opposites of each other. All right? So I'm going to do the same thing. X minus 2 times x minus 2 is x minus 2 squared. The middle term goes away. So this and this combined with these two are opposites of each other. They go away. Okay? That's kind of the hard part. And then I take these two and multiply, and we get minus 9i squared. Now, if you can get that much, the rest is cake. So we square this, and it becomes x squared minus 4x plus 4, and then plus 9. Or y equals x squared minus 4x plus 13. Go back in this video and look at the first way I did this. You know, like by the distributive property, and just have a bunch of, distributing 3 terms to 3 terms. This is much easier if you understand it. It's just harder to understand. Okay, what I suggest you do is this. Take number 2 and try doing the same thing. Pause the video, do it on your own. Okay, I'm assuming you've tried it on your own. Let's go through it together. So again, a is 1, so I'm going to distribute the negative, x minus 5 minus square root of 7i, and x minus 5 plus the square root of 7i. And notice if I put the first two together, you've got these are the same, minus and plus, those things. We have what are called conjugates. Okay? So let's multiply it out. And I'll tell you what, at this point, if you haven't tried it on your own, try it. Okay? What you'll end up with is x minus 5 quantity squared. The middle term goes away, and then we get negative 7i squared, which is the same as plus 7. And now it's x squared minus 10x plus 25, and then plus 7, which is y equals x squared minus 10x plus 32. Okay? Harder to understand at first, but once you understand it, it's way easier. Okay, now, how can we use that to factor this, given that that's a 0? Well, remember, what do you do if you can't factor by inspection? And you can't factor this by inspection. You cannot. You divide. Well, do you really want to divide this into g of x? I don't. So what I'm going to do is this. I'm going to find the quadratic that would have this 0. And remember, I know another 0 too. I also know there's negative 2 plus 2i. Okay? So I'm going to find the quadratic that gives me those two zeros, and then I'm going to divide that into g of x. So we'd have x minus negative 2 minus 2i. And I'm not writing y equals here because I already have g of x equals, so I don't need that. Okay, I'm just finding the quadratic. And then x minus negative 2 plus 2i. Okay, so we'll distribute x plus 2 plus 2i, x plus 2 minus 2i. And by the way, I suggest you do this on your own first. Okay, let's group those two and those two together, and now we have conjugates. So we have x plus 2 quantity squared. Middle term goes away, minus 4i squared. So we have x squared plus 4x plus 4, and then the negative 4i squared is also another plus 4. So it's x squared plus 4x plus 8. And what am I going to do? I'm going to divide that into g of x, right? Because that's how you factor when you can't factor by inspection. Notice on these problems up here, I wasn't asking you to factor by inspection. I was asking you to put things together, right? So here, in other words, here I gave you the parts and you're assembling them back into the equation. Here, I'm giving you this equation and asking you to pull it apart. So what do? Try and factor by inspection. If you can't do that, then divide and write divisor times quotient. So let's take the divisor, which is x squared plus 4x, plus 8, and divide it into x cubed plus 7x squared plus 20x plus 24. And this is long division, right? You can't do this by synthetic division. So what times x squared gives us x cubed, x, then we'll multiply it, x cubed plus 4x squared plus 8x. Subtract the whole quantity. Remember, we better end up with a remainder of 0. So that x cubes go away. That gives us 3x squared plus 12x plus 24. Now, what times x squared gives us 3x squared plus 3? So we have 3x squared plus 12x plus 24. Subtract that, and we get a remainder of 0. Good. Now, what do? We write divisor times quotient. But something I want to point out, this is the divisor, right? But I'm not going to write that. I am going to write the divisor, but not that. Why? Because I want to factor it. This is not the divisor factored. What's the divisor factored? This thing over here, right? That's what gave us the x squared plus 4x plus 8. So I'm going to write the divisor, and the divisor is x minus negative 2 minus 2y times x minus negative 2 plus 2y. That's the divisor. What's the quotient? X plus 3. So remember, the main thing you always got to go back to, no matter what else you do, is if you can't factor by inspection, you divide and then write the divisor times the quotient. That's got to be like foremost in your mind if I'm asking you to factor. Up here, why didn't we divide? Because I was not asking you to factor. I was asking you to put it all back together again. Here, I'm asking you to factor. By the way, a quick comment I want to make. Leave it like this. I'm not saying you have to, but leave it like that. The reason is because some people would say, well, shouldn't I distribute the negative? Yeah, maybe, but it's actually better to leave it like this. Let me show you why. Let's say I give you the, and you don't need to write this down, just listen. Let's say I give you the 0 is 5. Okay, what's the factor? X minus 5. Okay, let's say it's negative 7. It's x plus 7. Fine, that's the factor. Let's say it's negative 3 plus the square root of 7i. Okay, so what's the factor? X minus negative 3 plus square root of 7i. And if you leave it like that, it'll be easier to tell what the 0 is from the factor. Let me show you what I mean. Let's go the other way. Let me give you a factor, and you don't need to write this down. I'm just trying to tell you now why I recommend you not distribute the negative and just that you leave it like that, okay? Okay, I'm going to give you a factor, but don't write this down, just listen. And I'm going to ask you what the 0 is. Okay, so if the factor is x minus 12, it's pretty easy, the 0 is 12. If I give you x plus 71, it's pretty easy, it's negative 71. If I give you x plus 5 minus 3i, then what's the 0? Quick, can you tell me? All right, it's harder. What it is negative 5 plus 3i. Yeah, that would be the 0. But notice if I write this, if I write x minus negative 5 plus 3i, it's much easier to see that, okay, the root's obviously negative 5 plus 3i. It's just easier to read the equation if you leave it like this rather than like this one. Okay, so you may write this one, but I suggest you not. It's easier to just leave it x minus whatever the 0 is. Okay? All right, and again, you don't need to write any of that down. I'm just kind of trying to convince you of why you want to leave it the way it's written right now, like this, as opposed to actually distributing the negative. Okay? All right, here we go, another one. Hopefully it's the last one. Yes, good, because these problems are long. Okay, 5i is 1 0, so negative 5i is another 0. Now, what would this be? X minus 5i and x plus 5i. Pretty simple. So it's x squared minus 25i squared, which is x squared plus 25. Okay. So what's the divisor? X squared plus 0x, right, because we're missing the x term, plus 25. And then what's the dividend? The dividend is x to the 4th plus 3x cubed plus 21x squared plus 75x minus 100. All right, let's just do it. What times x squared gives us x to the 4th? X squared, let's multiply it. So we get x to the 4th, be careful here, plus 0x cubed. Be very careful. And then plus 25x squared. Now we'll subtract that. And we get 3x cubed minus 4x squared, and we'll drop down the 75. Okay, then what would that be? That would be plus 3x would give us 3x cubed, so now we'll multiply. 3x cubed plus 0x squared plus 75x. And then we'll subtract that. And we get negative 4x squared. You can put the plus 0x minus 100. So what times x squared gives us negative 4x squared? That'll be minus 4. So we have negative 4, and then we'll multiply negative 4x squared plus 0x minus 100, and good deal, our remainder is 0. So what do we write? Divisor times quotient. So h of x equals, now yes, this is the divisor, but again, I want to write this. I want to write the factors of the divisor, equals x minus 5i times x plus 5i. And now what's the quotient? X squared plus 3x minus 4. And now we'll factor that. Well, fortunately, it factors. But if it didn't, what would you do? You'd use the quadratic formula. But this is just going to be x plus 4 and x minus 1. But again, if it didn't, you just use the quadratic formula. Okay. Whew. That's a mouthful, that's for sure. I suggest you might want to go back and look at these problems. Again, I want to emphasize the difference between the first problems. The first problems is I'm giving you the parts, and you're assembling them all back into an equation. Okay? Here, though, I'm giving you the equation, and then you're pulling it apart into things that are multiplied. Okay, it's kind of like saying this. On these first problems, I'm giving you the 2 and the 3, and you're giving me the 6. On the second set of problems down below here, I'm giving you the 6, and you're pulling it apart into the 2 and the 3. First problem, I'm giving you the parts, and you're multiplying them together. The second problem, the problem's down here, I'm giving you the 6, and you're pulling them apart into things that are multiplied. That's why it's very important to know what factoring is, what the definition of it is. You need to know what it is you're doing. Okay? All right. So we'll pick up from there next time. Remember, basically all of this is going to be what? Degree 3 and greater that you can't factor by inspection. You can't factor by looking at it. In which case you divide and then write divisor times quotient. Now, obviously, there was some work you had to do here, before you were able to divide. But if all you do is this, you won't have done what I told you to do. You need to divide, okay? It's divide and then write divisor times quotient. All right. See you next time, mathletes. Have a good day.